Performance Tuning MySQL Server. In this nugget, we take a threefold approach to maximizing MySQL Server performance. By way of introduction, we'll begin with learning how to assess server status and load using a variety of different show commands. I'll then give you some targeted advice, of course giving you the skinny on your exam objectives, on how we can tweak memory parameters as well as query cache parameters. Both of these obviously have a great impact on the day-to-day running performance of your MySQL server. Let's get started. Accessing server status. Let's take a look at a couple important show commands that you need to be aware of for your DBA2 exam. The first of those is show variables. Now, show variables does nothing other than show server system variables. Now, variable is what you think it is. If you look at the root of variable, it's variable or varying data. And this is going to be representative of server level parameters that are set either at server startup in your MySQL configuration file, my.cnf for NIC systems, my.ini for Windows systems, or alternatively, many but not all variables can be set at runtime. In point of fact, there are actually some server variables that can only be configured during runtime. Now, the good news is that you don't need to memorize all of the server variables for your exam. That's crazy. You don't even need to memorize half of them. Just the general principles apply here, friends. The kind of variable information that we have available to us as DBAs are stuff like directory locations, where your MySQL installation directory is. That's your base dir variable. Your data dir variable, which we've discussed a lot so far, that's where your databases are stored. Server capabilities, the sizes of your caches and buffers, all of this stuff are represented as server level variables. Now then, we know that if we want those variables to persist across service and or server restarts, we would record those in our configuration file. When it comes to runtime configuration, we're dealing with the MySQL client, so we're working with the MySQL prompt, and there we would use the set statement. Now, you need to know for your exam, if you don't know already, that when you're setting a server status variable, or also called a system variable, from the MySQL prompt, you can run one of two different ways. You can set the variable globally or at the session level. Now, to do a global level variable or a server-wide variable, you have to be an administrator. You have to have wide privilege. Otherwise, if you're an ordinary MySQL user, you can pretty much configure your session however you wish. Show variables, as you'll see in the upcoming demo, can be run just straight without any other parameters. Or, of course, you can use pattern matching, show variables like, and then pass in single string delimiter ticks, a partial string to get matches on variables that begin with a certain letter or a certain pattern. And that's awfully useful if you haven't memorized that list of variables and you just can't remember specifically what the variable is called. We can look it up in the list. And then if we want to temporarily, just for our current session, tweak up that variable, we can do that. For instance, oftentimes I'll be doing table modifications and maybe foreign key checks, which are always enabled in a relational database system like MySQL, are getting in the way of whatever operations I'm doing on the table. So I might temporarily, at the session level, set foreign key checks to 0 to turn them off. Now there, it's implied that it's a session level command. I wouldn't need to put session in there. Other commands, it's more obvious. And I'll demonstrate that in the upcoming demo anyway. The other service status mechanism is the show status command. Now, the question is, what's the difference between a system variable and server status? Now, a variable represents a tunable, changeable, variable parameter. Now, status is something that's very volatile. You can think of a status as kind of an EKG readout. You know, you go to the doctor's office, or heaven forbid, the emergency room, and you get strapped to an EKG or a heart rate monitor, and you're seeing that data live as it's happening. That's kind of what show status does. Show status gives you the current activities that the server is performing. For instance, you'll see server uptime, queries that are currently being processed. Basically, it's a nice way to get a picture of current server load. There are related commands that we've looked at. We've looked at show process list. You'll remember that. That gives us a nice run of all the connected threads. Show status is a really nice companion show command because it gives us more information in terms of what's going on under the hood with the various components of the MySQL daemon. In particular, and in specific, the query processor and query optimization components of the daemon. There's also a short version of this command where we can just run status. And what status does, it's a brief snapshot version of show status. Show status gives you, in some cases, almost too much information. Actually, I would describe the output of the status command as somewhat of a hybrid between show process list and show status. You'll see when we get to the demo, I'll show you exactly what the output looks like, and you'll get a clearer picture from there. Tweaking memory parameters in MySQL Server. We've talked about it several times thus far, and the discussion is ongoing. One of the most important ways to improve the performance of your MySQL server is to throw more hardware on it. And this is going to be a function of how much doski you have in your IT budget, isn't it? I mean, one nice thing that many folks like about MySQL is because it's portable to different OS platforms. At least this is how it used to be. Maybe it's changed a little bit now in 2009 with faster and more powerful computers coming down in price. But it used to be that you could throw all this really nifty server software on a fairly low horsepower Linux machine and still get fairly good performance as long as certain subsystems were well tended. If you had a really fast network backbone and so on. Well, I don't know. That's a different school of thought that we'll reserve for a different time. Again, email me if you want to open that discussion, open that particular can of worms. The bottom line is memory equals speed. And that's certainly the case when it comes to query performance. So what we're looking at on this whiteboard are a number of methods, variables, and so forth that we can set. Again, we don't need to memorize all the variable names. I'm just giving you the general categories where we can configure memory usage in MySQL to increase or decrease performance in particular areas. Now, first, there's the question, well, how do we know what the optimum value is for such and so a variable? For instance, you might read somewhere that key buffer size variable should be 16K, the table cache should be 4, the sort buffer size variable should be 64K, and someone else says, no, the key buffer size variable should be 256 meg, and the table cache should be 256. There's the question always, and this just isn't with MySQL or with Linux, it's with really any client-server application or with any OS. Where do we go in terms of a frame of reference for getting some of these suggestions? Well, I have an answer to that. What you can do is just look directly within your distribution files. You'll recall, I'm sure, that in addition to your standard my.cnf or my.ini, the helpful and friendly MySQL development team gives you a number of additional sample option files. They have names like my-small, my-large, and so on. You may have ignored these files thinking, they're not relevant. They're actually quite nice because they contain, depending upon their size, small, medium, and large, deal with the number of options and the size of those options as they're pre-configured in those files. But it's nice because, for two reasons really. One is that these files are nicely documented and heavily commented. And number two, they contain nice starter suggestions in terms of assigning values to some of these system variables. So please keep that in mind. Now then, let's take a look at this first one. Maximum number of simultaneous client connections. This is controlled by a system variable called max connections. And there's the question, okay, we know that when we run show process list, we have a connection show up as a thread. So we can consider that connection and thread are roughly synonymous terms. And we ask the question, why would we want to cap our MySQL server at a particular number of simultaneous connections? Well, again, to get back to what I originally said, you may be constrained by that old rickety Linux machine that has a fast network card in it, but maybe not so much RAM, maybe not a particularly strong processor. Therefore, we may need to pare down some of our system variables to avoid overloading that particular machine. Second question, how do we figure out what the current load on the server is in terms of its maximum connections? The answer to that question is you'll want to run show status, and you'll look for a status variable called threads connected. And over time, over the course of several workdays, over high times and low times, peak periods and lulls, you should get a pretty good idea of the general usage of that MySQL server, and then you can set max connections appropriately. Another important system variable that deals with memory and deals with server performance is the size of the table cache. The name of the variable actually is table_cache, and this is an integer value. The default value is actually 64, and this is going to determine the number of tables that MySQL can track and open and keep track of. And you know the purpose of caching. It's to keep frequently accessed data up in memory to be able to serve it up extra fast the next time it's called. And again, with memory or with anything that we're putting in cache, we want to make sure that it actually belongs in cache. Therefore, we would turn again to the show status command, this time looking at the status variable open tables. Not open sesame, but open tables. And I can't tell you this often enough. Please don't worry about memorizing these variables for your exam. Just know the general flow. Know that in terms of tweaking memory parameters, we would look at these general categories. You certainly should understand these 4 points that I'm discussing, but you don't need to necessarily memorize the exact name of each variable. You probably know by now, if you have IT experience, that it's not necessarily memorizing the names of every single variable. That's impossible. The question is knowing where to find them. And you know by now that the MySQL reference manual is your ultimate source for this stuff anyway. Third, we have the size of the MyISAM key cache, and we've discussed this in a previous nugget. So you know that the MyISAM key cache is that memory allocation area that stores pointers for your MyISAM indexes. To get a read on current MyISAM index usage, you'll want to see how often are those keys being hit up. Show status, there's a couple important variables there. There's one called key read requests and another one called key reads. Now these have underscores in them. Key_read requests, key reads. The general flow here is that you'll find that show status gives you a tremendous amount of data on which you can take practical action. Finally, we have the size of the InnoDB buffer pool. Now, what the heck is that? Well, there's actually 2 buffers or memory areas for InnoDB. Remember that the InnoDB storage engine is a transactional engine, and therefore we have a buffer pool for the data and index information. That's right here what we're talking about. First of all, it's controlled in your configuration file or at runtime by twiddling a system variable called InnoDB buffer pool size. Moreover, because InnoDB is, as I said, transaction safe, it relies upon a transaction log to record transactions before they're committed to the InnoDB tablespace file. So there's actually a log buffer as well, and therefore another system variable called InnoDB log buffer size. So there's buffer pool size and log buffer size. Those are system variables that you can pop in your option file, size them accordingly. They do have default sizes. You can read about the skinny on those if you want to in the MySQL reference manual. Tuning the MySQL query cache. When you consider that your MySQL server is doing query retrievals most of the time, at least in an online transaction processing or OLTP environment, heck, even in an online analytical processing or OLAP environment, MySQL is still doing a lot of query retrievals. We can see that tuning the query cache is going to be one of the principal ways to speed up performance of the server from a functional standpoint. Now, there are a couple crucial principles here that I need to get across from an exam standpoint, but they're just as important for you to apply in your business lives as well. First of all, know that the MySQL query cache is global, that you set this once in your option file and it is going to affect all of your users, all of your threads, all of your clients. Now, that makes sense. We wouldn't want it any other way, I wouldn't think. After all, if user 1 runs a particular select statement against your MySQL server, you would want that select statement, both the actual statement as well as the query results, the execution plan, the whole ball of yarn, to be kept into RAM, super fast access, such that user 2 can run the same select statement and then be able to take advantage of that super fast cached data. So the global nature of the MySQL query cache is perfectly logical. Now, one of the biggest surprises, and it's an unfortunate surprise to many MySQL DBAs, is that the MySQL query cache is completely case sensitive. And it's not only case sensitive, but it's space sensitive. Now, you'll have to take it up with the MySQL development team for the reasons why this is, and it's beyond our scope for the exam objectives. You just need to know that MySQL query cache will generate 2 different storages, 2 different execution plan caches for these 2 queries, even if they're identical after the from statement. In other words, if a user does select star from with all capital letters and another user issues select star from with all lowercase letters, those will not be cached in the same plan. As crazy as that might sound to you, it's true. Now, the take-home message, the way that we live with this as MySQL DBAs, is the C word, isn't it? Consistency. We want to make sure that we're submitting our queries as consistently as possible. Therefore, you'll want to work with your MySQL application developers and database designers to make sure that if you're submitting the same query in 2 different stored procedures, that you have space by space and case by case, letter by letter, identical structure to make sure that you're using the same query plan for those queries. By the way, there's also the fact that you're wasting RAM by generating 2 query cache objects for these 2 queries if they're pulling back the same rows. Now then, how do we control the size of the query cache? One way to see what's set in terms of your existing variables would be to run, for instance, show variables like query underscore cache %. That'll pull back only those server variables that deal with the query cache. You can also see status related to cache by running show status like qcache. As you'll see in the upcoming demo, all of the status variables that pertain to the MySQL query cache start with qcache, which is pretty logical too when you think about it. The 3 main system variables that are used to control the size and operation of the MySQL query cache are as follows. And you see here, this little screenshot I have shows example output from a MySQL configuration file. Of course, all of the options I've given you in this entire nugget would need to be placed in the MySQL D portion of that option file. Please don't forget that. The query cache type system variable is going to either turn on or turn off the query cache. Of course, all things being equal, you'd want the query cache to be on, wouldn't you agree? Query cache size is exactly what you think it is, the upper limit of RAM that you're devoting to the MySQL query cache. You'll want to choose this number carefully based on the amount of physical RAM you've got available on the machine. Third, query cache limit. This defines the upper boundary of how large an individual query result can be and yet still be eligible for caching. The default limit is 1 megabyte. So in terms of these examples here, I mean, select splat, that's a pretty broad query, and actually that brings another best practice to mind besides consistency. If you don't already know this, if you're fairly new to database administration, although I've been pretty liberal in my use of the asterisk in these examples, you'll certainly want to be very parsimonious, in other words, very stingy in your use of the asterisk in your production environment. Please try to stay away from the asterisk. only bring back the columns that you need, and certainly use where, group, all of your SQL keywords to filter your results to bring back only those rows you need. I know that seems obvious, but of course, to our purpose in this nugget, we have issues like the query cache to consider, and this query cache limit system variable. This is going to define the maximum size of the query result that can be put into this MySQL query cache. I mean, there's a balancing act here. We want to put as much data as possible in RAM, but we certainly don't want to hobble the server, because if the server is genuinely overloaded, the server is effectively good for nothing. It's demo time. In this demonstration, which we're going to undertake on Lin Nugget 1, we're going to look at setting tons of variables. We'll look at status, load, memory, and query cache, and we'll take a look in so doing on how to get a gauge on our server performance and server load, looking at some of those helpful show statements with which we began this particular nugget. Let's dive into that demo and have some fun. Okay, let's get this party started. We're measuring server load and tweaking server variables on MySQL 5. As promised, we're on Lin Nugget 1, although everything we do in this nugget, of course, ports over to other operating systems with no modification whatsoever. As you see, I've logged into MySQL Server, and the first command I'm going to show you is that truncated version of show status. I mentioned that we could run just status with no other parameters to get a really nice snapshot of many things. And let's just take a look and see what's up. Status gives us the MySQL version. It gives us our current credentials, our connection ID. If we're attached to a database, it gives us that. As a matter of fact, let me use the world database and then run status again. And now I'm connected to world as my default database. I'm not using secure sockets layer. Our server version, our connection. You see that we're on localhost. We're not coming from over the network. We're connected via Unix socket file. Our server level character set, our database, our client level character set, our specific socket file location, server uptime, and then some metadata here. Number of connected threads, slow queries, open files, table flushes, open tables, queries per second. Really nice dashboard here, really nice. Somewhat redolent of show process list in terms of it gives some of the same information in terms of the connection ID, the user, the host, the database, and so on. It's a nice command, status is, when you're walking into a situation. For instance, you might be a MySQL consultant and you just want to get a feel in 5 seconds or less on what's going on the target server. Show status is going to give us quite a bit more information, as you see as I scroll up. So you'll definitely want to make use of the like and pattern matching options to cut down on the amount of data. Aborted clients, aborted connects. Here we have a tremendous amount of status information pertaining to the InnoDB engine. By the way, the MySQL literature does talk a little bit about saving memory in terms of storage engines. You can disable the InnoDB storage engine specifically by using the skip InnoDB parameter in your option file, not that you would necessarily. The question comes up, though, with some DBAs. There are so many other storage engines in MySQL, and I'm sure even though they're not all activated, they're probably taking up memory. So if I run show engines, you see I have 8 engines here, and they're all available. Obviously, I have InnoDB, but I have merge, I have black hole, I have CSV, I don't have federated, that's by design. I have archive, of course I have my ISOM. And actually you cannot get rid of the ISOM engine. That's literally just baked into MySQL. And although it's fairly easy to disable InnoDB, as I said, it's just simply a server level variable. The only way that you can actually uproot or uninstall the other storage engines to save yourself some memory is to compile MySQL from source. There's not an uninstall feature as such once you've already laid down the binaries. The good news is we've talked about compiling MySQL from source earlier in these nuggets, and if you've been watching them in sequence, you already know that. Now then, Let's bring back show status. And right underneath the InnoDB options, we see our MyISOM key options that were referred to. Remember, key reads, key read requests. We have some key write data as well. Max connections, open files. We referred to some of these variables, some of these status variables, as indicators to give us some data to go on as we then turn around and start setting some server level variables. Now, since this is a brand new, freshly installed server, I don't have a whole lot of data here. You see that most of my data is just 0 or very low numbers. Quite frankly, I'm the only user. This is a development workstation, so we can't expect to see that much data anyway. As far as the query cache is concerned, as I promised you, those status variables are contained in several entries here, all beginning with qcache. Qcache free blocks, free memories. You want to pay particular attention to qcache hits, for instance. When a query is run for the first time, it's going to come from the disk, isn't it? Subsequent times, that exact same query is run. Remember, case and space sensitivity. We want that query to come from the query cache. So we can expect that over time, the qcache hits status number is going to increment. So we do want to see that value go up quite a bit. Not cached, you see my number's fairly high. Qcache queries not in cache. You can read the MySQL reference manual to get detailed exposition on what all of these status variables mean. Alrighty then, so much for status variables and accessing those. Once you've analyzed the status and you have a pretty good idea of your current server load, it's then time to start setting system variables either interactively here at runtime from within the MySQL client or persistently in the MySQL option file. Let's do that next. Before we start setting variables, it might be a good idea to see what the server's variable list looks like right now. Of course, to do that, we can run show variables. And again, we can expect to see quite a list, alphabetized by default. And you'll see that some variables take integer values, some are essentially Boolean, on or off, others give a directory path. The full documentation for all of these is, you know where, in the MySQL reference manual. Data-dir, some are old friends, we've been there and done that. Others may be brand new. InnoDB, again, is kind of startling how much you can do configuration-wise to the InnoDB storage engine in particular. I just saw max connections. There it is, max connections. Again, with so many of these, if you have some idea, even if you don't memorize the full name of the variable you're interested in checking the current status of, you can at least get close by using pattern matching. For instance, if we know we're looking for something that includes buffer size, we can say show variables like, and then just pass in %buffer_size just to get a subset of stuff back. And of course, we can check the current running value in the value column. If you know the specific name of the variable, again, you would use like. That confuses a lot of people, but you put the entire name in single ticks. So we would say, for instance, if we wanted to look for our SQL mode set at the server level, we would type show variables like SQL_mode. And it would tell us here on my server, I have nothing set in my option file, or I have nothing set at the global level in my set statement to give an SQL mode. Now that actually brings up a good point. Before we look in our option file, let's quickly cover that set statement. Remember, set can be used with global or with session. For instance, what I just did here, ignore the error here, I forgot to put in an equal sign in my first run. But what I've done here is typed set session SQL mode equals traditional. And the second word here, session, could just as well have been global. Now, if I run my show variables again, like SQL mode, it's now telling me that my current session level SQL mode is traditional because my current running server, at least in this particular session, has gone from null or blank to traditional. Now, if I were to open up another session, log in, you'll note that SQL mode comes back as blank still. Come back to my first session now. And just as easily, I can set my session SQL mode back to nothing by passing in empty parameters. Now another syntax actually is you can either use the session or global keywords with space, or another terminology actually is to do set at session dot and then the name of the variable that you want to set. You see? One of those 6 in one, half dozen in the others. So session is going to persist only for this session. As long as I have the super privilege, I'm a root user or the equivalent, I can set a global parameter that will actually affect the entire server. However, the best way to do global level changes is to open up your option file. I happen to have Pico open now, etc mysql my.cnf, and if I move on down to the MySQLD portion of the file and open up some lines, we can start adding some parameters here that will persist after server restart. So for instance, if I wanted to add some query cache parameters, I could just simply type query underscore cache underscore type equals 1, 10 megs, query cache limit equals 2 megs. Save this file, reboot the MySQL daemon, and I guarantee you if I show variables and take a look at these variables, these new numbers will be representative of my new query cache settings. It's as simple as that. None of this is really rocket science. If anything, if you're an experienced MySQL administrator, this is review if nothing else. However, I hope that this demo has been useful for locking in this data, and you'll certainly be able to tackle with 100% success any related questions on your MySQL DBA2 exam. Performance Tuning MySQL Server Review. I hope that now that we've concluded this nugget, you have a much better idea of some of the things that go into making a MySQL server go faster. We first looked at an introduction to assessing server status and load. We looked at a couple useful show commands. There was show variables and show status. Between show variables and show status, you should really have your thumb on the heartbeat, or I guess to be more medically correct, your finger on the pulse of your MySQL server. Once we have that information, we can then turn to setting important performance-related and memory-related system variables. We looked at tweaking memory parameters and the query cache, both of which can be awfully helpful in making your MySQL server perform better based on your business environment. I hope that this has been informative for you, and I'd like to thank you for viewing.